Son, before I die, I want to give you your inherit, but son, all of this is yours. Someday, all of this will be yours. It's a big theorem, but it's in integrate. You need to integrate to solve the area.
Why? Why? Why do I need to integrate? I need some help. Oh wait, I got an idea.
Son, because I am a good person, I will help you.
So to find the area under the terrain, we first must find the points in which these two functions intersect. So to do this, we equal them. X equals x squared. And in this way, we must make it equal to 0 and find the point. So then it would be x squared minus x equals 0. We factorize x equals x minus 1. And we find our two roots. Here x is equal to 0, and here x is equal to 1. As we see in the graph, this occurs in 0 and 1.
And then we need to integrate the equation. So we need to integrate the and then we need to substitute the values 1 and 0. And because it's a 0 here, then all the values in the equation are equal to 0, and then we don't need to do the second substitution. And then this will be equal to 1 over 6.
Okay. So now in the next part, imagine we had to do this terrain into an infinite amount of small rectangles. So in this case, we made one in which its coordinate in x is a certain interval I, and its coordinate in y is f, being this line, the straight one, f of x, and the curved one, g of x. So in this way, we can describe as the base as c interval c, comma c, g in that part, and the same here, but in the case of f. So to find its height, it could be seen as the change between the point f in c1 in ci minus g in ci. So now we need to find the change in x, which can be defined as the point b minus the point a divided between the number of rectangles that we would do, as seen in this function. So now we also know that the area of this rectangle would be base times height. And if we were to write it by rectangles, we'd say that it would be the sum, the end sum of each interval 1 with f of c1 minus g of c1 times its change in x. In which, if we find it in a different perspective, we can say that as the limit approaches infinity of the same sum, it approaches the area under the interval, or in this case, the integral of f of x minus g of x.
And then the limit definition becomes to an integral, and we can see that the integral that it becomes from this equation is the same that we integrate at the first. That is the f of x, that it could be x minus g of x, that it could be x to the square, to the x.